So thank you all for being here today. I will present web server-side attacks and how we can use this type of vulnerabilities to find bugs in CTFs and real-world applications. So some background about me. I'm doing my master's in cybersecurity at ETH Zurich. I'm also playing CTFs with WreckTheLine, and I've been doing security stuff for 6 years already. And my main specialty is web. So I know a lot of things about web attacks in general. So as some motivation, we're going to learn and discuss what are some of the most common attacks and how they work. By doing that, we also learn how to defend against these types of attacks and how we can make use of them in CTF as our bug bounty. So this is like a list of the common server-side vulnerabilities. It's not a complete list. There are many other types of attacks, but just talking about all of them will take a lot of time. And I think for this presentation, just going through everything that is on this list will be very helpful to get you up to date with what are the most common types of server-side vulnerabilities. So before we go more into depth, I'd like to do a short reminder of what the web is and how it works. So it's like the most used technology today, and we are mostly dealing with a configuration. We have like a client, and he's making requests to a server, right? And the server responds with some data back. So this is the model, and our main entry point will be as the client. We send some malicious payload to the server, and we make the server respond with some unexpected output that was not intended by the developers. These interactions will be mostly done via APIs on the server, and that's a short summary about how this works, right? Cool. So let's start with SQL injection. It's one of the most well-known vulnerabilities. So what it does, it allows an attacker to interfere with a query that the application does to a database. And by doing that, it allows the attacker to exfiltrate data and possibly even modify it, right? And that is important because if we do that, then if an attacker does that, then they can circumvent any access control that we might have in place. And it also could impact our integrity of the data and confidentiality. And in some cases, they can escalate this SQL injection attack to actually compromise the server, execute commands on the server, and do some lateral movement, and even do denial of service attacks. So it's like a very important vulnerability, and we should be aware of it. We should look for the patterns that are present and try to fix it in our code. So there are some categories of SQL injections. Inbound refers that we actually get the response, the text from the query. So we do a select and we get the data. And those can be error-based or union-based. Error-based is basically making an error in the SQL query, and the application will actually return us the error. If it's set in debug mode or in union-based SQLi, then we just return a new table that contains the data we want, and that will be outputted in the application by the application, right? And then we have inferential or blind SQL injection, where we don't actually get the data from the request. We just see some behavior. So that can be Boolean based, where we get yes or no on a specific query. And if not, we can do a time-based SQL injection. And with that, we can actually get data from the database, even if we don't see the full output. And there are some out-of-band SQL injections where the server does the query asynchronously and just returns us a response. So we cannot do blind or in-band SQL injection. We actually have to exfiltrate the data somehow, and that is primarily done via DNS or other types of exfiltration, maybe HTTP as well. It depends really on the database server. But those are kind of like the categories of SQL injection that we can have in the application. Okay. So this is how it looks like. This is the attacker. And pretend we're like on e-commerce shop like Emag, and we want to filter the items based on some category like gifts. Well, if the server is set up in such in an insecure way, then an attacker can actually intercept the request for the filter and modify the filter from gifts to an SQL payload. And if the application is vulnerable, then it will not escape or string, and it will input it directly into the SQL command. So as we see, we can close the code right here and insert our own SQL statements. And it's really useful if you know how SQL works, especially when crafting payloads, because you need to know some things like even as a black box attacker, you must know the number of columns, most importantly, if it's an in-band SQL injection. And we need to know the tables. Now, there are some database engines that have like a metadata table, like information schema, where we can actually get all the table names for that particular database, right? And that's very useful if we don't have access to the source code. And to get the number of columns right, we could, for example, do an union select, and we can try just insert the value as a literal, just do 1 until it works, right? So we select 1. If it doesn't work, we add 1 more column. If it doesn't work as well, we add 1 more column until we get the right amount of columns. And when we do that, what we get from the server should include our payload, right? We should get 1 as the name and description. And then we can start actually getting the tables from the database. And if we get the tables, then we can extract all the information from the database. And that can be important. We can get some passwords, which might or might not be hashed. It depends. We can get a lot of personal information, usernames, emails, etc., or shipping addresses, whatever. Like that is valuable data to an attacker. And in some cases, if the database engine allows it, we can actually do stacked queries. So we end this statement, and then we just do a drop users, right? To, yeah, just modify the integrity of the database and remove all the users from the database, which, as you can imagine, it's not very good, right? So this is how it would look like. This is a vulnerable example. So we can see that instead of properly escaping the username and password, we're actually just doing a select star from users. And we're just constructing the whole SQL query in the code, and that allows the attacker to basically end the query and just do whatever they want afterwards. How to prevent this? There are kind of 2 ways. We can just do prepared statements. So a prepared statement would be something provided by the SQL library that, so instead of manually concatenating the strings, we will just use a %s, for example, and we will just pass the username and passwords as arguments to the function. And the library would ensure that the proper sanitization is in place, and we will not allow us to escape the query. And another way to do that would be just using ORMs, or object relational mapping, to basically create objects in our programming language that are tied to the database. And usually the way to use ORMs is you don't write this query, you will just do something like users.get where, and then we pass in some arguments. And that will construct a valid SQL that is not vulnerable. But yeah, in this example, we can see that it's vulnerable. And it's actually a blind-based SQL. We just get a result if the login succeeds or fails. And as we discussed previously, this is a blind SQL injection. And how would we exploit this? We will basically have to automate, and we will basically have to, let's say we have like a column named username, and we want to return true when like this expression matches, right? Like and percent. So this will always return true. But if we append like an A before the percent sign, then we only get the usernames that start with A. And then we can brute force that further at AA and get usernames that start with AA. And by doing that, we can just try all the characters and get all the usernames that start with AA. Yeah, because it will be one point where we do AAB and there will be no user with AAB. So we know that the search actually, there are no users in the database that start with AAB. And if we want to optimize this further, we can do like a binary search, right? That'd be more efficient way to actually select the characters. And we can do that by using substring, so we only get like a substring of the username instead of the whole string. Cool. So that was SQL injection. Yeah, it's a very nice vulnerability. A bit of old school, like it's not so common anymore, but it can still be fairly easy to mess it up, I'd say. If you don't know about it. If you know about it, then it's very easy to mitigate using the two describe methods. Cool. Next is command injection. So this is pretty similar to SQL injection. So yeah, it's also a shell injection. It basically allows an attacker to execute operating system commands or even code that the web server is interpreting, something like Python or Ruby, etc. Yeah, and this is a pretty critical vulnerability because it allows the attacker to basically do whatever the web application can do. If you get like a command injection, then you can also do as well. So you can log into a database and read all the information, or you can use the web server to mine crypto on it. It has happened before, or compromise it to have the server be part of a botnet, etc. Yeah, so this vulnerability is pretty serious, and it can lead to compromise of even the entire infrastructure, depending on how that is set up. So how that works is pretty similar to SQL injection, but this is our payload. So if we know bash, then we know that if we have a command between $, parentheses, and close parentheses, then whatever is in here will be executed like if we want to do an echo and we want to get the result of ID, we'll just do echo $sign and ID in parentheses, and that will just print the ID information from Linux. But in this case, we will, the attacker does a curl that is doing to some backdoor or whatever. Whatever the attacker wants to do, really, and then it pipes it to sh. So the code will just be directly interpreted in shell script, and that's nice because it usually doesn't leave a lot of artifacts on disk. Because we could also do something like bin sh and then have the payload in the command argument, but it's much more likely that the command lines will be actually logged, right, by some kind of VDR solution, etc. And if we do like a curl into sh, then we can kind of avoid that as an attacker. But yeah, it's a pretty simple vulnerability, and if you look at an example of how it looks in code, this is command injection in Python. So if we get to this point, then we'll actually execute Python code on the server. And if we can execute Python code, we can also execute OS commands by importing OS and then just doing the payload from before. And how to mitigate this? Well, normally we shouldn't really evaluate programs that come from the users or arguments that come from the user, but in some cases we actually need to do that. Like imagine something like LeetCode or CodeForces, where the whole point of the application is running untrusted input, and for that we should have a sandbox environment. So in this sandbox environment, the user inputs some data, and it goes to the sandbox, and we get the result back. And for other types of vulnerabilities, like if we do an OS system with some data, we need to sanitize the data. Because maybe we append something like curl before the user input, right? And then the attacker can just do another command inside of curl, and yeah, ID. So that's kind of how to mitigate this. It's not a very challenging vulnerability. Like it's pretty easy to know. Like you can have some payloads that actually confirm if you have command injection or not, right? You can do a sleep, and if you see the request taking more seconds than usual, then you know that you succeeded. Because with this vulnerability as well, you can have it in-band where the output is actually returned, or you can have blind, which is the case right here, which you don't get the output, but you can actually execute commands. So it's kind of up to the attacker to figure these things out, and a big part of doing web research when you don't have the source code is just trying things and fuzzing and observe different behaviors depending on how the application actually responds to some queries. So it's very application dependent, just like no good general solution to find this type of bugs, and probably fuzzing is your best bet going forward. Yeah. Cool. Let's move on. So next is less critical vulnerability, but it's also very good to know about. It's about server-side request forgery. So what is server-side request forgery? Well, it basically allows an attacker to make the server actually request request a resource, and the web server is actually doing the request. So instead of having the client doing the request to the resource, we actually have the client calling the web server, and the web server actually does the request. That's basically it. And as well, it can be in band or out of band, so you can get the response from this request, or you do not. But even if you do not get the response, you can still cause some damage depending on how the endpoints are set up. Because you can have like some APIs that are internal only, and you could have something like clear database, and you do a GET request from that, and it clears the database. That might be used in some automation jobs, and it really depends on how the application and the organization is set up, right? But yeah, it can cause a lot of damage. But it really depends, right, on how everything is set up. So yeah, this is basically the example. Here we have some application that will make a request to the resource that is being requested by the attacker. We can see it have like content. So this could be a curl or other implementation. It's very application specific, and it will take the content parameter and do a request to the resource. And we can see from the IP of the resource, this is an internal IP, so it's not meant to be publicly accessible. And there can be confidential data and other types of data on internal resources. And they're generally not well protected because they have this assumption that everything is internal and everything is trusted. And you cannot break that chain of trust by doing an attack of this type. And yeah, like you can get some data from this, and we could yeah, and based on the data we can do other things, like in the next example. Here is a request to this IP, which is a specific Amazon AWS IP, which has some metadata. And what type of metadata? Well, in this case, we have like an access token to the AWS account, or yeah, the extra provider, and we can use the access key and secret access key and the token to maybe escalate privileges inside the cloud. So this is pretty cloud specific, but it's certainly possible to even compromise an organization that is cloud first, to say. Moving forward, I'm going to talk a bit about XML external entity. So it's another type of injection that allows an attacker to interfere with an application that processes XML data. So that can be used to view files and to interact with backend services or external systems. So this vulnerability can actually lead to SSRF that was previously mentioned, but it also has more capabilities, including the ability to view files in some cases on the system, and those can contain precious configuration files that an attacker can use. And yeah, that's basically how it works and how it can be used to exploit a web server. This is how it works. So this is the usual XML stuff, and yeah, XML has this notion of entities. which can be external. So if we want to include a file, in this case, etc password, and we want to include it in the XML, so this will be done by the XML processor. And in that case, it will actually include the file etc password, and in this example, it will actually return the contents of the file. And it also can be used to request HTTP resources as well. So this is an example where we use some another thing of XML, which is DTD files. So they are like external XML and configuration files that can be used in in out-of-band exfiltration. So we want to exfiltrate a file. We actually we make a request to our IP, and we use some custom variables, right? So this is very XML specific stuff, but it's pretty important to know this type of vulnerability, because it could easily arise if you're dealing with XML data. Now, the good part is a lot of the XML libraries that are in use today. So this behavior is like mostly it's disabled by default. Right? Or it's limited in its capabilities. But yeah, that doesn't really mean that it won't be present. So yeah, it's important to know that it should not be enabled by the developer, basically. And it's not always possible, right? Because I'm sure some documents somewhere by some entity will actually require using those entities in the XML, and yeah, it's pretty difficult to reason about what the best solution is in that case. Maybe have a sandbox as well that processes XML files, but that's kind of the gist of this vulnerability. Cool. Next is path traversal or local file inclusion. Also directory traversal. They enable an attacker to read arbitrary files on the server that is running the application. So that can include the application code and data, credentials, and sensitive files on the file system. And in some cases, if you have like a file upload somewhere, you can actually even take control of the server by including a file that will be used by the server as code, which is a good example in PHP. So how would that look like? Let's say you have this type of pattern where we are requesting a file name, but instead of going just to /gift.png, we actually take the file name as a parameter to some script that is running. And why a developer might want to do that? Well, maybe they have some like compression algorithm that is running, or if you want to have different sizes for the same image, you can append like some size. So it's a bit more flexible, right? But it also can open up some vulnerabilities. Like in this case, just escaping from the current directory that the application is in, or it tries to get this file from. Just do .. until you get to the root of the file system, and then we can read files from etc. And in the case of path or in the case of local file inclusion, well, we have this PHP example, and we have the specific keyword, which is include. And what this does is basically it will interpret the file as code, as PHP code. And that can be bad because, yeah, if you can execute code, you can escalate your privileges. And actually, some recent research on this is that you do not actually have to upload a file in PHP to get the include to actually do the malicious script that you want. You can actually use PHP filters to actually inject arbitrary data in your request. Because, yeah, PHP has some filters. So if you want to base 64 decode a file, you would use a PHP filter with some base 64 C, and then you have like a resource, right? And there's some very nice exploits on GitHub that they just manipulate this part, so they don't care about the resource at all. It can be any file on the file system, and you can manipulate the filters based in some way such that you can get actually just PHP system on Git. So yeah, if you want to read about this, it's very interesting how it's done. It's basically using different character encodings. So you go from UTF-8 to some Korean, how do you say, from UTF-8 to another encoding, and it adds some characters to the beginning, and then you encode it and decode it, and you can actually get whatever payload you want. So very interesting stuff there. Cool. Next is insecure direct object references, or IDOR. So it's a type of access control vulnerability that basically arises when the user input is used to access objects directly. Yeah, it's kind of a long name to basically say broken access control, and it was popularized by OWASP Top 10 in 2007. Yeah, it's just one example of access control implementation mistake, and it can lead to access control being circumvented. They're mostly associated with horizontal privilege escalation, but they can also arise in relation to vertical privilege escalation. And how it works, let's say we have an account on this bank site, and this is our ID, this is our user ID, and we visit our site, and it's all good. We get the response that we expect based on our user ID, right? Now, what happens if we change the ID? We change it by 1 digit, so 5 instead of 4. And if the access control is not implemented properly, then we actually will get the data for this ID, which is not our account, right? So that can lead to private information disclosure, and in some cases to actually manipulate the resources. So we could do just all the crude operations in some cases. So create, read, update, or delete the resource. And how would we circumvent this as an attacker? So we can use sessions and cryptography to actually verify that after we log in as an account, we get like a session, and we use the session to instead of ID, we use the session to get the account, right? But what do we do with objects that we cannot store in session, right? So if we take, for example, Twitter, we have a bunch of posts for our account, and each post has their own unique ID. Well, then we need to create some kind of system or just have checks everywhere, but that can lead to bugs on the resources. So the attacker should have like the proper permissions only for their tweets, not for the tweets of other users, right? Because then you can modify or delete them. There's no simple solution for this. There are some libraries like Action GUI, where you actually write declaratively your constraints on the database. So you have the users, and you say that the posts can only be modified if the user owns basically the post, which is kind of a nicer way to do things. If not, you have to verify for each endpoint that you can actually modify the resource. And if you have like a lot of resources, so you don't only have posts, but you have messages, files, whatever, it can get pretty messy. So even in big systems, I feel like this is kind of a common way of vulnerability that is kind of still present in today's applications. So yeah, the vulnerabilities mentioned previously, the kind of more niche, like websites today kind of took care of them. So and they're more easily detectable by automated tools. But in the case of IDORs or broken access control, well, even automated tools, they don't know what your business objective is, right? So they don't know if another user is allowed to delete the post from another user. So they cannot kind of detect those type of vulnerabilities. So it's easier to find them, I feel like. And yeah, for defense, basically just check everywhere that everything is implemented properly. And that depends on the specification of the application, obviously. Cool. Next, so server-side template injection is when an attacker is able to execute native template syntax to inject the payload into a template, which is then executed server-side. So what is a template? Basically, when you have the web application, you want to dynamically generate a page such that this says maybe hello user, right? So instead of doing it all on the front end, you generate the page and then you send this to the user. And server-side template injection is when, well, actually, the attacker kind of controls this part. So not just the user part, but the whole string that is going to be generated and served as the page. And they use this as an attack vector for template injection. And how they look like, this is a flowchart to kind of determine what kind of template engine is running in the background. So you can start with, there are some characters that are specifically used by the template engine to differentiate page contents from actual interpretable actions. So if we start with this payload and we actually get the result of 25, that we know that it passed. And to further figure it out, we can insert a comment. And, if we get just a B and not a common B, we know that it's Smarty. If not, we can test other things. Like we want to join this string with Z, and if that passes, it's Mako. But maybe the most common and well-known is Jinja in Python. So Jinja is actually using double braces for any type of expression. And in this case, it's just doing 5 times 5. And if it works, then we tried it with a string. yeah, because that's how it works in Python. And if it is Jinja, then we just get 5 files, right? And that's pretty powerful because the template engines, like, they allow the developer to have like a lot of flexibility in how to use them. So you might allow a developer to actually use like functions that are available in the programming language. Can use if statements. So it's basically another, it's a programming language inside of your programming language. And you can use that to execute commands, OS, or do a denial of service. Then again, it depends on the template engine, but that's kind of the way to do it, I'd say. So let's move forward. Let's talk about insecure deserialization. So before talking about deserialization, we need to talk about serialization. So it's just the process of converting complex data structures, such as objects and their field, into a format that we can pass to the client, and then the client can pass it back to us. And we kind of understand what was meant, right? So it's just basically a protocol on how to understand an object. And it makes life easier for developers because you don't need to keep a lot of state. We can just serialize an object. We can save that in the database. We can read that back. We can convert it to an object in the programming language. We can maybe send that to the client to keep some state on the client. And we did that from the client as well. Now, why is this insecure? Well, because not all objects are created equally, right? So we might have a class user that is serializable into some data, but we might also have like a class command that just does system in the constructor, right? Or it has some fields and it does system somewhere. And that's a problem, especially with weakly typed languages, because you don't really know what object the user just sent you, right? You need to deserialize it. You look up some symbols. You find the class in your project, and you actually instantiate the object. And yeah, it just happens that there are some objects in maybe your dependencies that do just random stuff. Like, this could be maybe an example. I know there's one in Spring where you can actually just pass an XML as an URL, and then this will be interpreted as a configuration file, and you can get RC from that. So remote code execution, just from that. You just have a class, and you call the constructor in it. It takes one string. You pass that string along, and you get RC, right? So yeah, like a project can have like hundreds of classes that you don't even know about, and they're usually they're usually known as gadgets by the attacker. So you can use different gadgets to get RC or other type of vulnerability. This is an example in PHP. This is how serialization looks like in PHP. It's like a text format, so it's pretty easy to reason about as a human. Sounds like a machine. You would have all binary data, and all the fields will be binary. So in this case, we have an object that is of class order, and it has 3 fields. One is product, and instead of the value of the actual product, we can modify it with some malicious payload. And depending on how this class is set up, it goes to the website. And in this case, the application developer decided to add the wake up function, which is what a function that is called. when the object is constructed, basically. And it does this sequence of actions, right? Which could lead to something like exec or system or popen, or just eval for more interpreted code, right? And yeah, even if there is no such order class in the project, there are publicly known gadgets that we can use to actually just get RC without even knowing what the backend looks like. We need to kind of figure out the main framework that the website is using to use those gadgets, but we can also just brute force all of them and see what results we get, right? So it's a really interesting vulnerability, which is kind of underrated, I'd say. It's definitely, yeah, pretty cool vulnerability. Yeah, next is denial of service. So when I specify denial of service for web applications, I'm not talking about distributed denial of service where you have like 10,000 bots that you use to down a server, but I'm mostly talking about vulnerable pieces of code that just do too much computation for one request. So maybe that would be a query where you search for something, for some IDs, right? But you don't actually limit the number of IDs that you can search for. And the attacker can just do this 1 million times, right? And you'll have 1 million requests to that database. And yeah, unless you have like 1 million users, you don't really expect this amount of requests per second, and that can just slow down an application and cause it to be unresponsive for other users. So yeah, this is kind of like the difference. So in distributed denial of service, you mostly care about overloading the bandwidth. But in a denial of service, you mostly care about just exploiting a bug in the server code. So whatever, if you can make it crash, that's from the perspective of an attacker, because then the server will have to restart the whole application, and then that takes time. Or you can just make it query a bunch of stuff, and that will also take a lot of time. So yeah, there to circumvent this, well, you can still apply the rate limiting. So you kind of limit the amount of requests that this particular user can do to the server to some API endpoint. And that can be helpful for some APIs which are generally more computational heavy by default, so there's not much you can do in the code about it. But yeah, that's like one way. Another way is it's pretty hard to say, because it really depends on the application and what you intend to do with the application and what the users expect from your application, right? So you need to take those into consideration. And even for rate limiting, you need to implement that properly, because the attacker can just get more machines and do a denial of service attack anyway. Like they might not require 10,000 machines, but only 10, right? To do the same amount of damage if there was no rate limiting. So yeah, it's a pretty hard thing to actually mitigate, and it really comes down to the design of the application and the business requirements, right? So there's no easy solution for this as well. Cool. Now, let's talk about something a bit more advanced. So HTTP request smuggling is a technique for interfering with the way that a website processes HTTP requests. It's primarily associated with HTTP1 requests, but some versions of HTTP2 can be vulnerable as well. So what exactly is request smuggling? Well, if we kind of consider how the modern web application stacks are configured and how everything is set up, well, you typically have like a front-end server that is kind of a load balancer or gateway. And then we'll have microservices or some other backend services that actually do the processing that you want from that API request, right? And what this front end server can do, it can do rate limiting and access control and so on. So those are kind of two things that we kind of want to circumvent as an attacker. So it's good to know this technique. And if we look at this payload, why does this work in the way that it does? Because we send to the gateway one single request, right? Just one request, and then it gets split off into two requests on the backend server. Even though that is not what we actually sent to the gateway. And we see if we had implemented some sort of access control on the front end, then the front end server will just see a post to slash, and that is okay, and will not allow us to access slash admin. But because we do the request smuggling, then the request gets split up in the like transferring part between the front end and the back end, and we get both requests executed in the back end. And yeah, that happens because of, in this case, transferring coding chunked. So the front end server, in this case, takes priority. So transferring coding chunk takes priority, and it sees this whole request as one just one request, right? With some data and so on. Actually, think that, well, no, actually, sorry. The front-end server actually just takes the content length. So it does not interpret the transfer encoded chunk, right? Because, yeah. But the backend server does. So how transfer encoded chunk works is that you specified in the body the size that you're going to send. In this case, 0, because we want to terminate the request. And will not take content length into consideration where both are present. And so the backend server sees that the HTTP request ends here, and it sees some more data on the line, and it will just interpret that as a new request. So those are some kind of confusions between the front-end server and the backend server, because usually they're not implemented using the same frameworks. You kind of want the front-end server to be more performant, to respond to more requests, and the backend server can actually do just process the data, right, and return response. Yeah, that's a cool way of doing that. And actually, my live demo will be showing one kind of request smuggling vulnerability. We'll see a bit later. Cool, and I think this is the last one. Race conditions. What are they and how they might appear in your application? Well, they're mostly related to business logic flows. They kind of happen when a website processes requests asynchronously and concurrently. and without any safeguards. So you have multiple threads, and they all try to increment. Yeah, I think this is the most basic example. You want to increment a variable. Well, when you do that, you actually have to read, and you have to write value plus 1, right? And if you have multiple threads, then it can happen that thread 1 is here, and then thread 2 is also here, so they read the same value. And when they write, then T1 will just write the same value as T2, which is not intended, right? Because you wanted T1 to increment it, and then T2 to increment it afterwards. So you'd have from 0 to 1 to 1 instead of 0 to 1 to 2. Yeah, that's kind of how it works, and you could see this happening in SQL statements as well. I think that's the most known case where this vulnerability can happen. Let's say you have a gift code for a website, and let's say that this just gives you a discount of $5, right? So when you actually do the request to apply the gift code to your order, what the application might do is, well, just check the coupon code, right? We check in the database. We get the information from that, let's say, value and expired. And then the web server will say, okay, invalidate this coupon code because we have used it. So we don't want the users to actually use the same coupon code multiple times. And you can see like it's the same as with the increment example. If you do multiple requests at the same time, well, you can have a lot of threads that arrive at the execution point at the same place in time. So you have like multiple threads, and let's say they all pass the check. They get the same data from the database, and then it doesn't matter that the coupon gets invalidated because we have already passed the check that was previously set up, and we actually get $5 discount for every thread, right? So yeah, this is how it will work. Like you have like 3 threads that actually applied the coupon to our order, and then we have 2 threads that arrived too late or were out of sync and they did not pass the check. And how would we mitigate this as a defender? Well, it's pretty complex. There are some safeguards that we can do. So let's say that we want our web server to process. So we have multiple threads, right, running on our web server, and we have user 1, and we always map user 1 to this thread. So even if the user 1 does multiple requests, they'll have to wait for each response from the thread, right? So that's one way to do it, and kind of saves you a lot of trouble. If not, what you can do, you can actually go to the database part and just use transactions. So you basically invalidate any transaction that is not valid, because in our first example, we invalidate the coupon code, but we don't actually check in the application code that the coupon was invalidated already, right? So if you use transactions, then we can set this as to have like a rollback. Such that the discount is not applied anymore, right? So that's another way. We could use something like mutexes or semaphores to actually keep the critical section, to make sure that the critical section just runs not concurrently, but in order. But yeah, it's a really nice type of vulnerability, and I think not something that many developers think about when developing their applications. And you might even escalate this further, like not just with gift cards, but think you have like a rate limiter that that does the unsafe increment, right? So you the rate limiter could be set to 10 requests per second, but if the increment is not implemented properly, then you can do a lot more than 20 requests per second, because each thread will just increment the same value that was previously set. So you could have like, you could escalate this to maybe 100 requests per second, which it's a significant increase, right? That means like you don't need 100 bots. You can just do it with 10, for example. Yeah, and that was it for the theoretical side. I think we have like 20 minutes left, and I would really like to present a CTF challenge from a recent CTF called Line CTF. So it was a really fun challenge for web, especially. They had a lot of great web challenges, and they were all white box too. So you would actually get the source code for all of them.
Dragos, just 1 second. So I just want to remind you that we'll have to leave this room at 7:20, 7:25. They're going to start a new class. So just a kind reminder. Thank you. The presentation is going great.
Yeah, thank you. Yeah, I think I won't take long with this, right? Just want to show you how this really looks like, and how you can use the knowledge gained in for a CTF, for example. So we have this this code. Well, actually, it's in a jar, so we don't actually get the full source code, but we get the binaries, which are Java compiled applications, and we can pretty easily reverse that using JADX to look at the source code. And how this application is set up, we have an app that is running internal only, and we have a gateway that just proxies all the requests from our gateway to the internet application. So let's quickly look at the app and see what it does. Yeah, it's not a lot of code, so I'll try to go quickly through it. We look at the Line CTF package name, and we're mostly interested in the controllers, right? Because those are basically the endpoints. And we see we have an external controller that just says external page, and we have an internal controller that outputs some name. And what's important, we have this validate name that is an annotation. And if we look at the annotations, we can see this context build constraint violation template. And yeah, if we search on Google for this, it's pretty easy to see that we have a server-side template injection, right? So that's kind of our goal. We need to execute, we need to get to this endpoint, basically. And if we look at the Docker Compose file, I've added this port for debug only. So the app initially did not have the ports set up. So you can only access this app from the from the gateway. But because I set it up, I can actually just open burp and just go to localhost 1990. And we see index page. And if you go to API external, we see external page. And if you go to API internal, I think it expects like a name. Let's see it. Let's look at the logs. Request method get is not supported. So that's pretty good to know. We can use burp, and the most important feature of burp is the repeater tab. You don't really need anything else. And let's change this to a post. And it did not work because it did not like the content type. Yeah. Application. JavaScript, I think. Okay. So wait, actually, let's look at the code a bit more. So if we go to internal, yeah, it's a post, and it just wants the name in the but it actually wants JSON as the content type, which I forgot. Content type. Oh, it's just application JSON. Yeah, not JavaScript. Okay. And we actually need to provide a valid JSON. Okay, so it did fail because we did not pass the actual name constraint validator. It checks like 32 characters, and they're only A to F. So let's verify that by just submitting 32 A's. And let's see if we get, yeah, we get welcome AA. But we actually don't want to provide a valid name because we want to get to the important but build constraint violation template. So this is kind of server-side template injection, right, as we discussed. And we can search for payloads. And we can see like the common way to kind of exploit those type of vulnerabilities. We just do a 1+1 and we get some error, right? And yeah, the goal is basically to get an expression language that actually gets us RC. So this would be basically the payload. Yeah, let's try it and see how that goes. And because we don't get the output, we would have to do like an out-of-band exfiltration, right? So that took some time. Let's see if we actually can execute commands on the host. So I'm using request repo to do an out-of-band exfiltration, and we see that we actually get a request with curl from our command. So we know that this works, and if we can access API internal, then we can execute commands on the server and actually get a flag. But we cannot do that, and we will see why. If we now open the gateway, we check the gateway module, and we see the routes, and we see that there is a blacklist. So there is some kind of access control that is used in the application to not allow things like that. And we can see that there is one thing called there's one pattern that it matches against, and that is internal. So we cannot actually access any internal APIs. And if we check that, so the port was 280, and we get the index page. And if we do API external, then it actually works. Okay, so we have let me just throw this. Yeah, I'm sure it didn't work. Okay, moving forward. So yeah, we want to basically manipulate the gateway to just call the API internal endpoint, and we cannot do that because it's been set up to not allow it. And this is where the interesting part, and where I spent most time looking at. Let me just copy the payload, and I'll explain why it works. So I talked about request smuggling, and I have this payload, right? So I need to unset update content length to make it work. So the gateway will see this request, right, with the transfer encoding chunked, and it will process it as it was one request, but actually in the backend, it will be split up into two requests. And it's actually doing a post to API internal. So yeah, that's the attack that we previously discussed. And let's see if this works and if we get a flag. We see that it's taking quite a bit of time for it to execute, which is a good sign, and we get the post with a flag. So this is one way to circumvent access control using, so we have like two vulnerabilities. One is internal, and we cannot access it, and one is external, and we need to actually find a way to smuggle a request to get to the vulnerable endpoint. And I thought it was a pretty cool example. Like, we have two vulnerabilities, and we need to chain them to actually get the flag. And yeah, for the payload, we do a transfer encoding chunked, where we specify how many bytes we have left in the payload. This is a hexadecimal number, 11E. We input or payload to the internal endpoint, which is API internal, with our JSON that contains the exploit, which just does a curl with the file name flag from the file disk, and we use request repo to actually exfiltrate the output. And then we specify a 0 to basically end the transfer encoding chunk. And that's very cool because it bypasses all the attack patterns that the developer put in the application. And there was also some checks for post requests and whatever, and we just use put. So yeah, that's one way to circumvent it. Cool. I think I'm done. I'll quickly check the questions to see if there are any. Oh man, there are a lot of questions. Not sure how much time I have left.
Yeah. So I guess I'm happy that there are many questions, because last times we had too few. And what we're gonna do is we're gonna discuss them all, and maybe I don't know, try to find some answers and come back to you with them. But please choose one if you wish. Where are those questions? Did you get the link to
Yeah,
them?
yeah, I do have it. So
Yes. So far, nobody knocked at the door, so we can spare some time here still in the room. So yeah, feel free to answer them or any of them. And again,
okay, do you need to master SQL and web development programming before you can start learning web attacks? That's an interesting question. That's basically how I started doing CTFs. So I was just doing web development for fun, and also was very fond of SQL. And with that, I also learned a lot of tricks on how to actually use SQL as a developer. And when I got into my first CTF, the first challenge I solved was basically an SQL injection where you had the column names blacklisted, so you could not use them. And you had to do some interesting joins to actually create a pseudo table that had different column names to union that to your application. So I think it definitely helps, like especially in these kinds of vulnerabilities that are more technical, right? On the other side, you could just spend a lot of time doing automation. So you take a CV that's been popping up in the news, and you use that to scan a lot of websites, and you report that to the bug bounty programs. So that also works. I think there are like two ways to go about it. Yeah, so I can answer the rest of them in the Google Docs, if that's okay.
yeah, they'll be great, and maybe we can discuss them then at a later time, and we'll get back to you. I don't know, with more questions, I guess. Paul, did you want to ask that question?
Yeah, I wanted to ask about the Java application. Where was it handling the requests, and why you had to specify 1.0 or 1.1, the second request?
Did you hear the question?
You're talking about this?
Yeah, the bug. Yeah, I don't know if you can hear. In the bug request, I saw that the second post had the different HTTP version. Does it matter? Like the 1.1, 1.0?
No, I don't think it should matter. Yeah. I think most web servers just process 1.0 and 1.1 basically the same, so there's not much difference there.
It was the method in this case. And this request modeling, it's inside the like Java, how it handles. I didn't quite understand where it was the request modeling exactly.
Yeah, so so what this gateway does, it's actually a Spring product. If you want to build some, where was it? I think, yeah, there's a file that JText does not show me. So I will actually need to save all.
Does it have a custom implementation of it, or it's something generic?
It has like a custom file that it parses. Yeah, this YML file. So if you want to build like an API gateway, you specify some routes, and you specify the URI and what filter should be applied to the route. And what actually happened in this application is that you have the request on the gateway, and it will just, instead of using the default Spring gateway implementation, it will actually just do a request. Yeah, the server basically create a new request from your data. So that's where the smuggling happened. because the request library from the request library from Spring did interpret content length and chunked as two separate requests. So in the end, we had both requests that went through to the backend.
Yeah.
So yeah, so that's just an implementation.
Did you see it, or you just tried request marking them?
Actually, I checked the version, and it's a pretty old version, and it's not documented that it's vulnerable to a CVE, but some later version was vulnerable to request smuggling. And I just used the same payload, and it worked on this previous version as well.
Thanks.
Yeah. Problem.
Okay. Okay, so I guess we will have to wrap it up. I want to thank you very much for this great presentation. You went through quite a few of these attacks, and they were like very clearly specified. I personally definitely enjoyed the overview. And again, I just want to thank you much for your time and your patience. And I want to reassure you that these kind of talks are very healthy for our community. So thank you again for coming. Please give a round of applause. Hopefully some of the students here are gonna find their way to the CTFs and beat you eventually, right? That's the plan. All right.
Hopefully.
Thank
you very much. Yeah, and if you want to contact me, you can find me on Discord, Twitter, LinkedIn. So
We can
if any
also
more questions.
we can also reach you through FedEx, right? Through Phineas.
Yeah, of course.
Okay. Then we are in close contact in that case. All right.
Cool. Thank you very much.
Enjoy your evening.
Yeah, enjoy your evening. Bye.
Bye-bye.